Hi, my name is Ahmad and I'm going to talk about the techniques for steam sterilizing laboratory waste. Primary author. The primary author on this paper was Tim Coney. Tim Coney is a researcher scientist in AMSCO research and development. And this is what I can found about him. Introduction. The traditional method for steam sterilizing petri dish and other laboratory discards is processing at 250 Fahrenheit in a gravity displacement sterilizer. Laboratory discards are typically packaged in polypropylene biohazard autoclave bags that are either complete sealed after filling or have a contracted opening for air stem exchange, and except for this opening provide complete containment of the enclosed material. This article study examined the efficiency associated with different processing techniques for laboratory waste. Both agar-laden disposable petri dish and typical laboratory discards were processed. The effects of processing temperature and waste contaminant systems were investigated. Now we're going to move on to the method. Monitoring equipment and Eagles Model 2013 sterilizer with a 1626 chamber was used for this testing. Biological indicator were also used to evaluate the effectiveness of each sterilization process. Comparison of processing temperature. Two types of loads were evaluated. Disposable polystyrene petri dish containing solidified agar, approximately 4 kg for each cycle, and typical laboratory discards such as glasses, pipettes, gauze pads, disposable syringes, gloves, and ruled absorbent cotton. Load material was randomly placed in polypropylene biohazard bag. So this is the two type of loads. Both categories of load material were processed in each test cycle. Repeated 250 Fahrenheit and 270 Fahrenheit gravity cycles generalized load temperature profiles, which were analyzed in the context of equivalent time as T250 Fahrenheit. Comparison of packaging. Material preparation was identical to that described for tests conducted at the two processing temperatures. In this portion of their study, they used both spore strips and chimp sport to monitor the processes or the process. For petri dish loads, spore strips were placed in empty dishes and stacked next to the thermocouples. For laboratory discard loads, the spore strips were inserted into the lemons of the pipette. Since the focus of the tests was to compare packaging effects, test cycles were run using one type of load material packaged in both polyethylene and polypropylene biohazard bags. Thermal and biological data were compiled and analyzed as they were in the temperature testing. Petri dish were processed at 250 Fahrenheit with a 70-minute exposure time and at 250 Fahrenheit with exposure times of 25, 35, and 45 minutes. Laboratory discards were processed at 270 Fahrenheit for 45, 60, and 65 minutes. Now the result. Comparison of processing temperature. Table 1 and 2 indicate the come up times for each type of load. This is table number 1. For petri dish, more than 90-minute exposure was needed at both temperatures for all thermocouple area to reach the processing temperature. For laboratory discards, the 270 Fahrenheit cycles produced average come up time of 58 minutes, while an average of 77 minutes was needed at 250 Fahrenheit. This data indicate that petri dish are more difficult to sterilize than laboratory discard. Comparison of packaging. Table 3 and 4 list the come up time for loads processed in polyethylene and polypropylene biohazard bags. This is table 3 and table 4. Exposed to 250 Fahrenheit for 70 minutes required more than 65 minutes to reach temperature. The corresponding time for petri dishes and polyethylene bags was 48 minutes. A 45-minute exposure at 270 Fahrenheit to produce load come up time in in excess of 45 minutes for for polypropylene bags and 39 minutes for polyethylene bags. Laboratory discard in polyethylene bags exposed to 65 minutes at 270 Fahrenheit failed to reach temperature. By contrast, polyethylene bagged discard at 10 to 70 Fahrenheit in 43 minutes. The biological results for 270 Fahrenheit exposure, polyethylene packaging of Petri dishes produce greater cell activity than polypropylene polypropylene biohazard packaging. The most dramatical effect was noticeable with a 35-minute exposure time for polyethylene packaged Petri dishes. 75% of the chemspore retrieved were negative for growth, while for those packaged in polypropylene bags only 28% were negative. For both type of packaging, exposure for 45 minutes at 270 Fahrenheit produced complete kill in chemspore, and in most of the spore strips, and positive occurred in a polypropylene bag. At 250 Fahrenheit, a 70-minute exposure resulted in complete kill in polyethylene bags, but left fractional positives in polypropylene bags. Now the discussion. More than 90 minutes were needed for a 4 kilogram mass to reach the processing temperature. Use of polyethylene packaging also accelerate load heat up. The data indicates that about twice as many positive biological indicators occurred in polypropylene bags that in polyethylene bags. This was observed for a sub-lethal exposure of 35 minutes at 270 Fahrenheit using 2 kg of Petri dish. To eliminate agar spillage, double packaging techniques can be used. At this time, they see the use of polyethylene bags combined with 270 Fahrenheit processing as the fastest, easiest, and most effective way to enhance heat penetration into infectious waste material. And this is my reference. I have two references, and that's it. Thank you so much.